Okay, pre-calc, here we go. Systems of elimination and substitution, elimination. Substitution we called 7-1, elimination we called 7-2. We kind of did them together. And we have some graphing things, but we're going to be rehashing this. Now, just really quick. Substitution, when do I use it? It's always the question. Use it usually when you've already solved for y, or sometimes solved for x. You know y equals this or x equals that. Then we're going to use substitution. We're going to take what it equals and replace it in the other variable. Elimination is used most of the time. We got to make sure the variables line up. And if you recall, we're going to pick one variable to eliminate. We're going to make sure that the coefficients on both equations of that variable are the same but opposite signs, inverses, so like 4 and -4. And then we're going to add and eliminate that variable altogether, leaving us only one variable to solve for. Then when we're done on both cases, we find a value for x or find a value for y. We're going to plug it back in to get the rest of the ordered pair. We're looking for ordered pairs. Now, in the past, when we did this, you're looking at two lines and you're trying to figure out where they crossed, if at all. They could cross and get one solution, or not cross and get no solution, or overlap and get infinitely many. But what happens if we did a line with a parabola? Parabola could possibly cross the line twice. It may only touch it once, it may never touch it, but the point is we can get more than one solution. But what happens if we did a parabola and a circle? Circles are still math. It's possible that we can get up to 4 solutions, crossing 4 different times. Maybe it doesn't cross at all. What happens if we get this? This is an ellipse with a hyperbola, with double parabola kind of thing. That's possible we have 3. So the point is not what's what, but the point is with different shapes, we can have a bunch of different possibilities for solutions. We can even have the dreaded no solution, parabola and a circle, and they never touch. So it's possible to have multiple solutions, multiple different types. Let's take a look here, get through some stuff quickly, and see what happens. First, graphing. All right. Now both of these are in that slope-intercept form, y equals mx plus b. And so here, m is 1/2, b is 3. And over here, m is 3, b is -2. Okay, so basically what we want to do in this kind of situation is graph and see where they cross. So I'm going to start here. B is 3, so the y-intercept is 3. So dot here on the y-axis at 3. And this says rise over run 1/2. Up 1/2. And then we will get out our ruler. Something straight. ID, it should go about right there. Boom, we got our line there on the first one. Second one, the y-intercept -2, so down here, B, never x, y, always y. Then this is at 3, so that means up 3 over 1. Remember, it's got to be a fraction. And so when we do that, we go, oh, there it is. Where do they cross? Right here at 2, 4. So 2, 4 would be my solution. That's solving by graphing. Okay, what if we have something like this? Same idea. Same idea. Your m is going to be 5/3, b is going to be 2. So we're going to put y-intercept 2 up 5/3. Uh-oh, 1, 2, 3, it goes too far. So instead of going up and right, I'm going to reverse and go down 1, 2, 3, 4, 5, and then I'm going to go left, as if it were negative over negative, canceling out. Down and left is the same as up and right. Okay? Usually I always go to the right unless I have to go backwards. So there's my little line. But what is this right here? Well, where's y equals -3? It's over here. X is -3 there, y is -3 here. That's the dot I have. So now I get a line going across. and it crosses. So when it's y equals, it will go across this way. If it were x equals goes the other way. So this is y equals -3, but I'll give you a little hint. If it went like this, that would be x is -3. So x equals -3 goes through the x-axis at -3. Y equals -3 goes through the y-axis at -3. But the solution is this point here on either case, -3, -3. The solution is right here where it crosses. Just so happens to be the same for both. All right, substitution method. Notice this one I like, substitution, good. Already solved, y equals this right here. So I'm going to take 5x plus 22, and I'm going to replace the y with 5x plus 22. -2x minus 2, parenthesis. Now let's replace the y. 5x plus 22, parenthesis, equals -8. See what I did? Took that, what y equals, and replaced it there. Now I have a new equation with only one variable. I'm going to distribute -2x minus 10x minus 44 equals -8. I'm going to do a couple things here. First thing, I'm going to put these two together to get -12. The second thing is I'm going to add 44 over here. Now if I add 44, I get 36. Divide by -12, and x will be -3. So there's x. There it is. So now I'm going to plug x back in. Where do I plug it back in? Well, plug it into the simplest looking equation between the two. I think this one looks simplest. Make that look like a 3 plus 22. So y will be -15 plus 22. We get y equals 7. Boom. So now my answer, go green, x, then y. Ooh. There's substitution. Do that every time. Every time we have solved for something. I know in the other in the notes we've solved for a y squared and plugged into another y squared. Elimination. Now for elimination we have to decide to eliminate one variable, x or y. It doesn't matter which one. I'm going to choose the variable with the I lost my picture. There it goes. With the smaller numbers, 3, -5. I'm going to choose that one. And so in order to get rid of the x's, I'm going to have to multiply each equation. So I'm going to go ahead and come in here and put parentheses, parentheses, and I want to multiply so that these two numbers end up being the same, but I want one to stay negative, one to stay positive. Well, that means I'm going to multiply this one by 3 and this one by 5. Distribute 3 times -5, -15x, times -8, -24y, times -9, -27. Distribute the other, 5 times 3, positive 15x, 5 times 5, positive 25y, and 5 times 5, 25. And you can see right here, I got what I wanted by multiplying. Now sometimes you only have to multiply one equation to get it to happen. Sometimes it starts off this way. But I wanted one variable set where the numbers are the same but inverses, positive, negative. So when I add them together, this is what I'm going to do. I'm going to take all this and add. Those cancel out as 0. -24 plus 25 is 1. Beautiful. And that's -2. I get y. Usually there's a number here I have to divide, but now plug -2 back in. Which one looks better? Well, I like the second one myself. So 3x plus 5 times -2. Make sure you plug it back into the correct variable. Very common. So 3x minus 10 equals 5. We will add that. Ooh, get 15. 3x equals 15. So x is 5, right? Because divide by 3. And so we'll take the y and we'll take the x and put them together, and we'll get 5, negative 2. X, then y. Always x, then y. So there was elimination. We've got to be able to add it together and cancel. Sometimes you have to multiply the equations to get that to happen. We want to have inverses, a negative and a positive. Now, two more. What if we had these with the square, but, oh my gosh. Okay, well, we're still going to do something here. I can't eliminate. It's not solved for a variable, but I can't eliminate because, why? Well, I can't add these together and get anything to cancel out. One's a squared, one's not. But I can take this and subtract it over here, giving me x equals negative 2y plus 1. I can go 1 minus 2y, but negative 2y plus 1. I'm going to cross that out. I don't like the way it looks. Negative 2y plus 1. There we go. Now I have solved for x. That was easy. Subtract the 2. Boom. Plug that back in over here because it's for x this time. And so we get negative 2y plus 1 squared, because this is squared, this is not, plus 4y squared equals 25. Now you're going to have to multiply that out. Remember, squared means times itself. So when you multiply this out, you get 4y squared minus 4y plus 1. Then you get plus 4y squared equals 25. So multiplying this out gives you this here. Yikesers. That's going to be 8, 4y and 4y, 8y squared minus 4y. And then I'm going to go ahead and just go ahead and subtract the 25. So I get negative 24 equals 0. For some reason I jiggle the keys and the lights turn on. Now with this I'm going to reduce. I noticed that 8, 4, and 24, I can take out a greatest common factor. Okay, so 4 goes in all those. I'm going to divide everything by 4, including the 0. 4 goes into everything. It'll shrink up my problem. I'll be able to do it a little bit simpler. So now I got 2y squared minus 1y minus 6 equals 0. And we're going to factor that. 2y and y. And I need a 3 here and a 2 there. And a minus plus. And I get 0. We should know how to factor. But that'll work. 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. 2y plus 3 will equal 0. So y will equal negative 3 halves. Also, y minus 2 will equal 0. So y will equal 2. Why did I put 0? 2. That looks good. So I get 2 different y's. What am I going to do with them? So go back a second. I wanted to solve, there's a squared, so I'm in trouble. But, oh, I can subtract 2 y's so that now I know what x is. Plug x into here, and I have to square it, which means multiply it all out, maybe with a box, and get this. Combine it with these like terms, 4 and 4 make 8. And then subtract the 25 here and get there. I notice they're all divisible by 4, so I divide everything by 4. And then I factor. Okay, so basically I did this in my head. And I got these things here. Solve each one and get negative 3 halves and 2. plug it back in. Plug it back in where? Whatever's easiest. Now, for me, whatever's easiest is right here. I mean, that's the same as this. It just moved the 2y. So I'm going to say x equals negative 2 times negative 3 halves plus 1. The negatives cancel, the 2's cancel. We get 3 plus 1, or 4. Okay, so my answer here is 4 negative 3 halves. There's one answer. Remember, xy. Oh, sorry, there you go. There's one. And then the other one is I'm going to take the 2 and plug it in and go x equals negative 2 times 2 plus 1. That's negative 4 plus 1, or negative 3. And so we get negative 3 and 2 as my other answer. Okay, now we're going to pause with that. I'm going to leave it at that. I have one other problem to try and do, but I think I've already gone long enough. Okay, so let's back it out, see the whole problem. Little cranky with this squared. We end up having to factor a quadratic, get 2 different answers. Let me put a 1 here and a 2 here for 2 different answers. Each answer has to be plugged back in to whichever equation seems simpler, and make sure your order pairs say x, y. Hope this helps.